three security cases we are having. So here, how many years data they have given? 5 years data they have given. Security X returns 15 rupees, 12, 15 minus 3. Security Y 12 to 0, 4, 10. That security 0, 10, 12, 15, 17. And the problem, this problem is made up of other with the probability. Okay. So with this information, you have to calculate the portfolio expected return and standard deviation. If Mr. Raghu wants to invest 40% in security X, means these are the funds, that is weights, or X1 we can say, or XX we can say. 40% on X security they have invested, and 25% they have invested on Y security, and Y remaining 35% they have invested in the Z securities. With this, we have to assume that each security return is uncorrelated with the return of securities or not. Either they have been correlated or uncorrelated. We have to evaluate. So this is for the case of three security cases. Okay. Previously, we have done the two security cases. Okay. So first, information is them. What is the information they have given? Weights first. So 15x written on the portfolio. Easy on the first we'll calculate. What is the return on first A securities? 15. Second year, 12. Third year, 5. Fourth year, minus 3. Fifth year, 8. So what is the probability? 0.15, 0.20, 0.30, 0.20, 0.1. So we have to multiply this probability into x. That is 0.15 into 15. 0.20 into 12, 0.30 into 5, 0.20 into minus 3. All these things. After multiplying, we will be getting the return on portfolio is 4.35. For everything, with the probability or without probability, return on portfolio is very easy. Risk on portfolio will be a little bit clumsy and a little bit confusion will be there. The individual will calculate. Okay. So by bar, written on X we have calculated, and written on Y we will be calculating. So returns on Y securities first minus 12 minus 2 0 4 2. What is the probability? 15%, 20, 0.20, 0.20, 0.15. So on Y securities we are having only 0.1% is the return. Similarly, we will be doing the average return for the Z also. So we will be getting 99.65. This is the average return for security X, average return for security by average return for security desert. Now, combining means we are doing the portfolio. So that's why you have to combine these portfolio. That is, now we are using the return on portfolio. RP is equal to R1X1 plus R2X2, R3X3. 1, 2, 3 అనొచ్చు, XYZ, ABC, whatever you want to do. So what is the fund we are investing on X? 40%, that is 0.4. And return 4.35, we got it. Second one is 25%. And return we got only 0.10. Third, 35%, by security 35% we are investing, and return we got it on 9.65%. Okay. So overall return on portfolio is 5.143 is the return on portfolio. That is return on X security, return on Y, and return on Z security. Combinedly, we got wholesale return is 5.143. Okay. Now we'll calculate the risk. So security wise, first we'll calculate the standard deviation. How we have calculated the security wise average return in the same thing, security wise standard deviation we'll calculate. Okay. First, risk on portfolio. Probability with X minus X bar, that is DX అని అంటాం మనము. 15 minus 4.35. Probability with X minus X bar. Next, probability with. So it is totally for how many years? For 5 years. So we got risk on security for first year, that is 7.91%. Next, similarly, we'll be doing what risk on security Y, 6.37%. And similarly, we are doing for the debt, 4.73%. After getting this, we have been calculating the standard deviation with the help of risk on portfolio by applying in this formula. Okay. After applying in this formula, we'll be getting 3.913 is the risk on portfolio. So here written on portfolio మనకు వచ్చేసి 5.43% and risk on portfolio is 3.91%. Okay. So this is about risk and written on portfolio with the probability, without probability. Okay, Actually, is also some of the important questions they have given, like that you can expect return on security investment X and probabilities, investment Y probability. In the financial plan, single index model, sharp single index model, alpha P, beta into RM minus RF. The single index model problems I will explain. We estimate the values of alpha, beta, and sigma of the securities to 1.5 and 3 respectively. If the market index is expected to provide a return of 20% with a variance of 120. With this, we have to calculate the expected with single index model. So what is the beta they have given? Alpha they have given 2 and beta 1.5 and the risk is 300. Return on market 20%, return on market square they have given 120. Sigma on market. Risk on market they have given 120. So with this, we have to evaluate the expected return on security by using the single index model. So what is a model? A single index model formula. Alpha plus beta into return on market. Alpha into 2 plus beta is 1.5 into return on market is 20. So with this, we'll be getting the 32% is the return on portfolio or return on securities with the Sharps model. Okay. Like that, we are also calculating with the help of second security also. Two securities model. Risk. So risk we are measuring with the help of standard deviation. So that's why we are including the beta. Return ki alpha include chestam. Risk ki beta include chestam. So beta, what is the beta value they have given? 1.5. 1.5 into risk on market square 120 plus risk on both the securities 300. So after multiplying this, after getting or calculating this, 570 is the risk on portfolio, which is associated with the securities. Okay. Same similar problems will be there with two security cases, single index model. So you can expect CAPM model and single index models, return portfolio, risk portfolio. So these are the problems which is related to your risk and return. Just now we have different problems with the help of weights, with the help of portfolio. Okay, please look at into this. Apart from this, I'll share some of my questions. Just give me 1 minute time. Screen కనిపిస్తుందమ్మా? Just now I told you debate capitalization model, a single index model. Yes, ma'am. If you want, you can take the screenshot of this. This is my notes for the debate capitalization model for single period of time. Present value of the share d1 plus 1 plus d to the power of 1 plus d2 e to the power of 2 up to dn to the 1 power. This is for one period of time. If anyone wants, you can take the pic of this, ma'am. Anyone is there? Please take this screenshot, ma'am. Okay, fine. Sorry. Now it is visible. Huh? Please take this screenshot. Very important for your formulas. Just give me a minute. Oh, fine. Okay. Everyone, please take this very important formulas for your risk and return portfolio. If you look at single asset, single asset risk will measure with the help of X bar and return risk will measure with the help of sigma and return will be measured with the help of sigma. So with the probability, the formula will be the summation Px. Without probability, the formula will be summation X by N or summation RY by N. And this is for single case and without probability and with the probability for risk summation pdx square under root without probability summation p dx square by n under root. This is the formula for the return for risk and return for single security with the probability and without probability. And return on portfolio, that is more than two security cases. Return on portfolio, two security cases, Rx or RC, we can say R1 X1 plus R2 X2. That is two security cases. Three security cases, R1 X1 plus R2 X2 plus R3 X3. This is for three security cases. This is a formula for the return on portfolio. Risk on portfolio. Please look at this. Risk on portfolio. Sigma 1 square x1 square plus sigma 2 square x2 square plus 2 into sigma 1 x1 sigma 2 x2 correlation coefficient between 1 and 2. The two security cases. Look at this three security cases. Sigma 1 square x1 plus sigma 2 square x2 square plus sigma 3 square x2 plus 2 into sigma 1 x1 sigma 2 x2 sigma plus correlation coefficient 1 and 2 plus 2 into sigma 2 x sigma 3 x3 correlation coefficient between 2 and 3. 2 into sigma 3 x3 sigma 1 x1 correlation coefficient between 3 and 1. This is the formula for the risk of portfolio for three cases. What is R here? Coefficient of correlation. And what is the covariance here? Please look at correlation coefficient, which is covariance of 1 and 2 divided by sigma 1 x1. Okay, R is xy on what is covariance again here? Sigma dx dy by n. This is without probability. With the probability, covariance is equal to sigma p dx p dy. Okay. Anybody want to take a screenshot? You can take the screenshot here. అగైన్ హ్యావ్ టు గో బ్యాక్. డైరెక్ట్ షేర్ అవ్వట్లేదు. ఓకే, తీసుకున్నారమ్మా? తీసుకుంటే ఐ మూవ్ ఇన్ టు ద నెక్స్ట్ పిక్ మా. నాకు పిక్స్ రావడానికి కొంచెం టైం పడుతుంది.
తీసుకున్నాను మేడం.
ఓకే, థ్యాంక్ యూ. ఐ షేర్ వన్ మోర్ మా. జస్ట్ గివ్ మీ మినిట్. అలా బ్యాక్ ఉంది. కెన్ ఐ షేర్ ఇన్ ద గ్రూప్ మా? గ్రూప్ లో షేర్ చేయనా ఆ పిక్స్? నాకు దొరుకుతుంది.
ఓకే మేడం.
నేను షేర్ చేయనా సార్? కొంచెం మీరు వాళ్ళకి షేర్ చేయరా సార్? సో ఈజీగా ఉంటుంది నాకు. కొంచెం నేను డైరెక్ట్ పంపించేస్తాను. 1 మినిట్ ఇవ్వండి. ఆ, ఎక్కడ షేర్ చేయండి సార్? మన ఇది అఫీషియల్ గ్రూప్ లోనేనా సార్?
దాంట్లోనే చేయండి మేడం.
దాంట్లో చేసాను. కొంచెం అది పిల్లలకి పంపించారా సార్? నా దగ్గర పిల్లల గ్రూప్ లేదు. పెట్టాను చూడండి సార్.
మేము అఫీషియల్ గ్రూప్ అంటే ఆ, దాంట్లో నేను స్టూడెంట్ని మేడం, అందులో నేను లేను. మన
మీరు
ఈ
స్టూడెంటా? నాకు చెప్పాలి కదా
ఆ,
బాబు ఫస్ట్. నాకు తెలియదు అందులో పెట్టొచ్చో లేదో. నేను తీసేస్తాను అందులో నుంచి. సార్ని అడిగి చెప్తాను నేను.
ఆ, ఓకే
కన్సర్న్ సార్ని అడిగి చెప్తాను.
ఓకే.
ఇచ్చేయండి ఒక్కసారి. సార్కి పెట్టి చెప్తాను.
ఓకే
సార్ మీకు గ్రూప్ లో పెట్టారు. ఓకేనా? నేను సార్కి పెట్టానమ్మా.
ఓకే మేడం. రాధాకృష్ణ సార్.
మీరు స్టూడెంటా?
అవును మేడం.
రాధాకృష్ణ సార్కి పెట్టాను.
ఓకే.
మీరు స్టూడెంటా? కళ్యాణ్. ఓకే
అవును.
ఫైన్. సార్కి పెట్టాను, సార్ పెడతారు మీకు. ఓకేనా? సో ఏమైనా డౌట్స్ ఉంటే
ఓకే
నాకు
మేడం.
అడగండి. నెక్స్ట్ డివిడెండ్స్
ఓకే
క్యాపిటలైజేషన్ కి సంబంధించి కూడా పెడతాను నేను. అది పెట్టేసి నేను రేపు ఎక్స్ప్లెయిన్
ఓకే
చేసేస్తాను. ఓకేనా? ఓకే ఫైన్.
ఓకే ఓకే
ఏమైనా డౌట్స్ ఉంటే అడగొచ్చమ్మా.
ఓకే మేడం. థ్యాంక్ యూ.
ఓకే. ఓకే ఫైన్.
సరే.
ఏమైనా డౌట్స్ ఉంటే మీరు అడగొచ్చమ్మా చాట్ బాక్స్లో. ప్రాబ్లమ్స్ ఎక్స్ప్లెయిన్ చేశాను కదా అవి.
ఏం లేదు మేడం.
లేదా? ఓకే. మీరు ఒక్కరే అమ్మ ఫైనాన్స్కి?
తెలియదు మేడం. వీళ్ళు ఎంతమంది ఉన్నారో ఒకసారి ఒక్కొక్కరు జాయిన్ అవుతున్నారు.
ఓకే, పర్లేదు. రేపు డివిడెండ్స్ చెప్తాను, మీకు ఎవరైనా తెలిసి ఉంటే మీకు గ్రూప్లో వాళ్ళకి చెప్పండి.
ఓకే.
డివిడెండ్స్ ఆల్సో యూ కెన్ ఎక్స్పెక్ట్ వన్ క్వశ్చన్ డివిడెండ్స్. దానికి సంబంధించింది కూడా నేను సార్కి ఫార్వర్డ్ చేస్తాను. మీకు ఒక్కసారి
ఓకే.
చూపిస్తాను, ప్రాబ్లమ్స్ ఎలా ఉంటాయో చూపిస్తాను చూడండి. ఇమేజెస్ కొంచెం కష్టమే ఉంది. ఒక్కొక్క ఓపెన్ అవుతుంది. నేను ఫస్ట్ పిక్ ఇందాక ఓపెన్ చేశాను, అది కాకుండా వేరేది ఓపెన్ చేస్తున్నాను చూడండి. సో దిస్ ఇస్ అ టూ స్టేజ్ మోడల్. ఇది ఒక ప్రాబ్లం టూ స్టేజ్ మోడల్. ఒకసారి ఇప్పుడు ఇప్పుడు కనిపిస్తుందా?
అది లోడింగ్ అవుతుంది.
ఇప్పుడు ఇప్పుడు కనిపిస్తుంది చూడండి. If you want, you can take
ఆ,
this screenshot also. This is two-stage models. So when the investors will be holding for more than one security cases, in that cases, he will be applying this two-stage model. The formula for this two-stage model is equal to P naught into summation n I is equal to 1 dt into IT dt into IGT to the power of t into 1 plus k to the power of t dn into IG2 ke G2 minus I1 K1. So here G1 is nothing but your first growth year period. Means how many years the constant growth rate will be maintaining. See here, always all the companies will not be providing the same growth rate. So based upon the economical environment factor, the growth rate will be changing. So based upon that, the growth rates will be there. So how many periods the constant of growth rate will be falling? That is first growth rate and second growth rate is G2. K is the cost of equity and N is the number of years the period has been achieved. DT is the difference. How many years you have been receiving that. Some people will be investing for 3 years, 5 years. DN maturity. Okay. So D is difference per share, G1 is initial growth rate, G2 is the long-term growth rate, N is the number of years. If you look at the small problem, the company's growth rate is 20% per annum for the last 5 years, and the same rate is expecting to the 5 years. So for the 5 years, 20% margin they will be included before it reaches to 6%. So the previous dividends we are receiving is 0.5 per share. With this, you have to calculate the share value with the help of the cost of equity 15%. Okay. So growth rate ఎంత ఇచ్చారు మనకి 20%. How many years? 5 years. Second is growth rate 6% and dividends. The dividends is 0.55 rupees and cost of equity is 15%. So first with the alpha, so the alpha of DN. DN formula is D naught into 1 plus G to the power of N. So dividends ఎంత ఇచ్చారు మనకి 0.5 into 1 plus growth rate to the power of 5. It is going to give 1.24 is the dn. So simply we are applying this formula. First part వచ్చేసి dt. How many years? 5 years. So 5 years వరకు we are taking 0.5, 0.5, 0.5, 0.5 for the period of 5. Student 1, 2, 3, 4, 5. 5 years వరకు you have to take it. 1 plus growth rate అంటే 20% కదా for 5 years. 0.2, 1 plus 0.2, 1 plus 0.2, 1 plus 0.2, 1 plus 5. How many years? 1, 2, 3, 4, 5 years. Divided by 1 plus 15% to the power of 1. First year, second year, third year, fourth year, fifth year. ఫస్ట్ పార్ట్ అయిపోయింది. ఇది ఫస్ట్ పార్ట్. ఓకే. ప్లస్ ప్లస్ ఏంటి డిఎన్. డిఎన్ ఎంత వచ్చింది మనకు 1.24 ఇంటూ 1 ప్లస్ 0.6 డివైడెడ్ బై కాస్ట్ 0.15 ప్లస్ 0.6 ఇంటూ 1 ప్లస్ 0.5 ఇంటూ ఎన్ని ఇయర్స్ మనకు ఓన్లీ 5 years. సో అందుకని ఇక్కడ మనం 5 తీసుకున్నాం. ఇక్కడ 5 ప్లస్ ఇక్కడ కూడా 5. సో ఆఫ్టర్ క్యాల్కులేటింగ్ దిస్ వీ విల్ బి గెటింగ్ ద present value of the share is rupees 10 rupees 0.9 paisa is the present value of the share when it going for the dividend capitalization two-stage model. Okay. If you want, you can take the pic of this one. If you want, you can take the pic of this.
ఓకే.
Okay. This is for two-stage model. two-stage model. Dividend capitalization లో single period HPR, current yield, holding period return, 2 years, and two-stage model. We have calculated the risk and return on portfolio with the probability, without probability, two security cases with probability, without probability, three security cases with probability, without probability. Also, we have done single index problem. We have done PAPM model. We have done Markowitz and Sharpe's model. Okay. If you want, I'll give the notes. I'll forward some of my notes to Radhakrishna sir. Concerned person will be there. So మీకు
ఓకే.
సార్ గ్రూప్ లో పోస్ట్ చేస్తారు. ఓకేనా?
ఓకే. ఓకే.
శ్రీనివాస్, మీరు స్టూడెంట్ అమ్మా? ఓకే, మీకు నోట్స్ కావాలంటే స్క్రీన్ షాట్ తీసుకుంటే తీసుకోండి. ఇంతకుముందు కొన్ని స్క్రీన్ షాట్స్ ఇచ్చాను. మీ ఫ్రెండ్ ఎవరైనా ఉంటే వాళ్ళ దగ్గర నుంచి తీసుకోండి మా. ఓకే. సో ఎనీ డౌట్స్ ఇన్ టుడేస్ క్లాస్? విత్ దిస్ విల్ కమ్ టు ఎండ్ టు దిస్ క్లాస్. ఎనీ డౌట్స్ మా?
నథింగ్.
Okay. If you have no doubts, you can leave the class. No problem. Yeah, you can use scientific characteristic for this capitalization.